Euclid Book 4, proposition number 3 is very tough. But if we take it really slow, we can actually get this done correctly. Now Euclid says he wants you to first of all draw a circle. And this circle is going to be ABC. But we're not going to label all the 3 points yet. We're just going to draw a circle and we'll label the points later on. The one thing we will do though is we will label the center here as K. And because we've labeled this as K, we have to use Euclid Book 3, proposition number 1, to find K as the center of the circle. And you know how to do this, because if you don't, you can go back to Euclid Book 3, proposition number 1, and I will tell you how to do that. Okay, now, once you draw this circle, okay, you haven't drawn any of these lines yet, just the circle, you will then draw a triangle right over here. And it will be DEF. You will then extend the bottom part of DEF out here to points H and G. Okay? Now then, Euclid then wants you to draw a line from point K to point B. And then he says, once you've done that, what we're going to do is we're going to construct a triangle here. You see this triangle right here? It's MLN, okay? This triangle is going to be circumscribed around this circle, okay? So it's going to be outside the circle. It's actually going to touch the circle. It's going to be outside the circle. And these 3 angles, LMN, MNL, and let's see, LMN, MNL, and NLM, okay, these 3 angles here are going to be equal angular to these 3 angles down here, DEF, EFD, FDE. I'm going to show you how to do this. Okay, first of all, we've drawn KB here. By using Euclid Book 1, proposition 23, you're going to draw angle BKA, and it's going to be equal to angle DEG. This angle here is going to be equal in size to angle BKA. Alright? But you're not done yet. No. Once again, you're going to use Euclid Book 1, proposition number 23, and you're going to draw a line, you're going to draw an angle called BKC. Here's B, here's K, here's C. Okay? And BKC here is going to be equal in size to angle DFH, which is DFH. This angle here is going to be equal in size to BKC. Alright. When you've done this, you're going to draw 3 tangent lines. The first one is going to be called LAM. LAM. The next one is going to be called MBN. Okay? MBN. And the third one is going to be called NCL. NCL. Okay? And they touch circle ABC because of Euclid Book 3, proposition number 16. And by doing this, we can then say that angle KBM, angle KAM, angle KAL, angle KBN, angle KCN, and angle KCL, all of these angles are right angles. Okay? Now, and we can do this by saying Euclid Book 3, proposition number 18. So if you want to go to Euclid Book 3, proposition 18 to see that I'm telling the truth, go right ahead. Now, let's take a look up here. We have a quadrilateral. Starts at B, goes to K, goes to A, and goes to M. Okay? So, quadrilateral AMBK has 4 angles. One here, one here, one here, one here. It's just like a ball diamond. If you were to add the number of degrees of all four of these angles together, you would get 360 degrees. Alright, now we've already established that KAM and KBM are 90 degree angles. So that's 180 degrees. You add 90 degrees and 90 degrees together, you get 180. Here we go. Angle AKB, and angle AMB, if you were to add those degrees together, you would also get 180 degrees. Alright. We can say that angle DEG and DEF are also 180 degrees. Okay, so let's go to DEG. There's DEG. And DFG, or DEF, sorry, not DFG, but DEF. DEG plus DEF comes up to 180 degrees. And that's by Euclid Book 1, proposition number 13. We already said earlier that angle AKB is equal in size to angle DEG. Because of that, we can then go on to say that angle AMB is equal in size to angle DEF. Okay? Because if this plus this is 180 degrees, and this are 180 degrees, and this is equal to this, then therefore this must equal that. Ta-da! Okay. Now, let's go to the next quadrilateral. We have CKBN. Alright. We can already say that angle KCN here, KCN, is 90 degrees. We can also say that KBN is 90 degrees. If you were to add the number of degrees of this and this together, you get 180 degrees. That leaves two other angles, CKB and CNB. And these two angles added together come up to 180 degrees. And that's because in a quadrilateral, if you add the four angles together, they come up to 360 degrees. Okay. We already established previously in the proof here that BKC is equal in size to DFH. Because of that, we can then go on to say that BNC is equal to DFE. Okay? Now then, we've already established that two of the angles of this triangle are equal in angle, or in degrees, as two of the angles in here. What's left? Well, if 2 and 2 are equal, then we can say by Euclid Book 1, proposition number 2, Euclid Book 1, proposition number 32, that MLN is equal in size to angle EDF. And so, you have drawn a triangle that has circumscribed circle ABC and is equiangular to the triangle DEF. That's the proof. I will tell you more in a future video, so stay tuned.